Hey guys, I'm here back with another math video. Today we're going to be doing AMC10A 2016 problem 24. I would do AMC 10B problems, but technically I'm not allowed to discuss them till tomorrow. So without further ado, let's get started. So try to solve it if you can, pause the video if you need to. And here is the solution. So they presented 7 possible solutions on the AOPS website to this problem, so there's many ways to solve this, but I just decided on the easiest solution in my opinion, and that is using similar triangles. Spoiler. So notice first that all these angles are all theta because all these isosceles triangles are congruent. AB is equal to BC is equal to CD, and all the sides are equal because they're all radii. So all these isosceles triangles are congruent, AOB, BOC, and COD. So all these are theta. Now, one rule that you'll need to know is that if given a circle, given a point in the middle, if you have an arc length, if you have an arc and you have an angle for that arc, say in this case 2 theta, because we're going to be working with arc CBCD, and this arc length is 2 theta, then a rule is that any point drawn to the edge of the circle, the boundary of the circle becomes theta from that arc. So, and it doesn't matter where it is. It could be over here. It could be over here. Whoops. It could be over here. It would all be theta. It's always 1/2 that center angle. So using this rule, what's interesting is that since BOD is 2 theta, we can use that rule and apply it to BAD. Since notice that A is on the boundary of the circle, just like this angle right here, so this is just theta. It's just a geometric rule that this angle is always 1/2 of the center angle. So if I'll rewrite that. If BAD is theta, and remember what I said, we're going to solve this using similar triangles. Notice that if BAE is similar to triangle AOB. Now why is that? Well, this angle is equal to this angle. They're both theta, and they both share the angle ABO. So by angle-angle similarity, these two triangles are similar. So since BAE and AOB are similar, that means BAE, just like AOB, is isosceles. And since we know AB is 200 root 3, just 200, sorry, that means we know that AE, since this triangle is isosceles, is also 200. And similarly, the other side, like before, is also 200. That's interesting. So how do we find the middle length here, EF? Well, notice that this triangle, this small triangle right here, is also the small triangle EOF is also similar to triangle BOC. And why is that? BC and EF are parallel just by eyeballing it. You know, common sense, they're parallel. And parallel angles, lines, form corresponding angles. So CBE is equal to FEO. And BCO is corresponding to EFO, so those two angles are the same, and by angle-angle similarity, EOF is similar to BOC. Okay, so if we can just find the ratio between these two triangles, we can probably, since we know BC, we can probably know EF, but we just find the scale factor between these two similar triangles. So how do we do that? Well, we know that BAE is similar to AOB. Maybe we can use that to find BE, and that might help. Let's do that. So, what are the ratios? Oh yeah, BE over AB equals AB over DA. So the short side divided by one of the long sides is equal to the short side divided by one of the long sides. Just the property of similar triangles, that the ratios of their side lengths are the same. So since we know AB is 200 and that Wait, oh, sorry, I must have wrote it wrong. It's not DA, it is OA. I can't read my own handwriting. Yes, it is OA. Since we know OA is 200 root 2, and we know AB is 200, we can just solve for BE. So 200 root 2 BE equals 200 squared. And actually, if you just calculate it, you get that BE equals 100 root 2. 100 root 2, huh? 100 root 2 is exactly 1/2 of 200 root 2, which is equal to 1/2 BO. What that means is that BE right here, this length right here, is exactly 1/2 of BO. And thus EO, the other half, is also 1/2 of BO. So EO equals 100 root 2 equals 1/2 of BO. Now we found the scale factor. Since the side of this small triangle is 1/2 the side of the big triangle, and they're both similar, that means that EF, therefore EF is 1/2 of BC. Therefore, EF equals 100, since BC is 200. So now we know what EF is. That's 100. The other two lengths are 200. And you add all these segments up to AD, and you get AD equals 500. 200 plus 200 plus 1 is 500. Now the seventh solution that AOPS also presented was that if you had a ruler and a compass and you brought it to the competition, which you could actually just draw the diagram out and just measure AD. And since 500 is significantly greater than the other answers, you could actually just eyeball it and just say, see that it's 500. That's a way you could get away with not actually solving the problem. But I wouldn't recommend actually trying that out on any future competition. So, hope you had a fun time, as much fun as you can have with math, which is a lot actually. I'll see you next week. OA is 2 root 2, so this is 2 root 2. And since this is symmetrical, I'll apply all my math to the right side too. EA is 2, and since the radius is 2, AC is 2 as well.